Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of graphing exponential functions. This is standard A.9D in the great state of Texas, and we are using item number 8 of the 2017 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a graph of an exponential function here. And in case we forget, an exponential function, if we just think of it in standard form, is going to be this y equals a times b to the x power, whereas a is going to either be your starting amount. It might be your principal if you're dealing with some type of investment and you're dealing with compound interest. On this graph, it's also going to be your y-intercept, because it's where the graph crosses the y-axis when x equals 0. Right? If you think about this up here, if I replace my a times b to the x with a times b to the 0, just substituting a 0, well, anything to the 0 is just going to be 1, so a times 1, y equals a when x equals 0. That is your a. Your b is your rate. So it's either going to be a growth rate if this term is greater than 1. It's going to be a decay rate if it is less than 1. And then you've got your x. So that's just your step. Usually it's some type of time frame. Years, weeks, months, or whatever. But that's the exponential growth. And that is, for each unit or each step. None of that, unfortunately, helps us with the actual question here, because look what it says. Which dashed line is an asymptote? This is the key vocabulary word. So if you knew all of this, it's still not going to help you. You have to understand this particular vocabulary word. It's not on your reference materials and it's not on your STAAR chart. So you have to know this going into the STAAR test. Okay, so what is an asymptote? Well, simply put, an asymptote is a line that a curve continually approaches but never reaches. And so it looks like at the end of an asymptote that it's just a flat line, that they are touching. But if you were able to zoom in, you would not be able to see it, them touching. Actually, you would see them, assuming you could zoom in far enough, that they're still far apart but getting closer. So we have our function here, and we've got two different lines that I'm thinking about. Definitely not t. This t line has nothing to do with anything. This q line also has nothing to do with anything. We just need 4 choices for our 4 F, G, H, and J answer choices. Either the S line or the R line. So take a look at this S line. It looks like this is just sitting right on top of that x-axis, whereas this R line, you see how it's getting closer? You can see that it's going to get closer to R, but I don't know if it's going to meet it or not, or possibly. We don't know whether it's going to eventually, depending on the curve, it might even go past it. It might continue to expand. If we were to zoom in on just this section right here, what we would see would be, let's say this is my x-axis, right? We would see a line that is, I'm going to try to draw it here, barely descending. And that's really, really zoomed in. And then you're like, okay, so it's going to meet a little bit later on. Now, if you get farther on, like -100, you're going to see it's going to be closer, but the more you zoom in, you're going to see it's like this. This is the definition of an asymptote right here, this S line right here. It looks like it's sitting right on top of it, but if you can zoom in, it's continually getting closer, approaching it, but never really meeting it. And for most of your exponential functions, unless they do something like a +7 or whatever, it's going to be the x-axis. So that's our answer H.